This recording shows how I used some iPhone shot video to create a Blender camera tracked scene into which I keyframed the screen recording of me using Blender to move Suzanne right and left and clicking the File menu to simulate the laptop screen. I added the animation of the Quit menu and additional Suzanne animation. I then used object tracking to simulate the picking up of Suzanne with masking to obscure the simulated laptop screen by my hand and Suzanne's ear by my thumb. I'm using Blender 3.5.1 and OBS Studio 27.2.4, working under Ubuntu 22.4.2, so things may look a little different to your operating system, but it should not make any difference. In Blender, I first set the output resolution to 1600 by 900, so the effects video, this tutorial and my laptop screen are all the same resolution. This is lower than I normally work at, but hopefully it should make it clearer for you to follow. The frame rate is 60 frames per second, the same as the iPhone video. I also set the output folder. In Blender properties, I enabled motion blur and transparent in film. In world properties, I set the world illumination strength to 0. I turned off overlays so I don't have the outline selection of Suzanne or floor guides. I then used OBS Studio to screen record the movement right and left of Suzanne in Blender, which is in full screen windowed mode, and then the mouse moving down the File menu to the Quit option. I then created a screen recording of the Wibbly Susan. This was crudely created by using these geometry nodes before the subdivision surface modifier to animate her vertices. The driver for the random seeds is #frame, and I keyframed the min-max amount. Then I made Suzanne disappear by keyframing sudden large movement of the Z-axis. Just a note that I use screen capture in OBS and not window capture, as this doesn't record dialog boxes. Not an issue here, but I thought I would point it out. Using Blender's video editor, I next trimmed the OBS video recordings, removing the OBS starting and stopping. I recorded this iPhone 8 Plus video at 1920 by 1080 at 60 frames per second. The iPhone's focusing optics are pretty knackered after a few drops, hence the movement pops in the video. The video has a sweeping movement towards the laptop at the beginning, giving good perspective movement for camera tracking. Then holding position in front of the laptop for the length of the previous screen recordings, animated menu option, and movement of 3D Suzanne prior to being picked up. These totaled 30 seconds. Then I continued the recording as I went to pick up the fake Suzanne. The tracking points on my hand are just bits of black tape. In Blender's VFX motion tracking, I added the iPhone video and used perspective motion model, enabled normalize, and set the correlation to 0.9. Here I show the manually chosen tracking points, mostly on the laptop screen, but I managed to get a couple elsewhere. I set the solve keyframes at the start and stop of the camera sweep down to the laptop. Note that as soon as you click the Solve Camera Motion button, the output format resolution is set to the same as that of the imported video, but you can change this straight away back to the resolution that you require. I got a first solve error of 1.52 and then after refining for focal length and optical centre, this became 0.27. I set the origin, x-axis and scale using these three tracking points on the laptop screen. In an animation editor for the created camera tracking scene, I deleted the plane, cube and light, then added the first screen recording, the one of Suzanne moving right and left and the file menu, to this camera tracked scene. This is added as images as planes. This add-on needs enabling in preferences. Also, for all these added planes, in their materials I set the blend mode to opaque and shadow mode to none, except for the animated menu texts that have fading, which have a blend mode of alpha blend. I then scaled and orientated the camera solver object constrained camera so that the simulated laptop screen of the screen recordings lines up nicely with the filmed laptop screen. I find this easier by enabling motion tracking and overlays so I can roughly orientate the camera. There is still a bug in Blender 351 in that I can't change the size of the tracking points. I did this orientation with two 3D viewpoints, one showing the camera view and the other to manipulate the camera. I fine-tuned the scale and orientation so that the video plane, which is the simulated screen, nicely tracks the laptop screen in the video. I find it easier to use rotate about the world origin, which was defined in the camera tracking setup to be on the laptop screen. Alter the first screen recording video plane's frames and offset in its materials to ensure correct running of the video in relation to the camera tracked scene. In this example, the video in the plane needs to start at frame 407 in the final video, so I set the offset to -407. The number of frames in the video was 748, all of which I want to play, so the frames is set to 748 plus 407, thus 1155. I decided the frame at which the menu is clicked and keyframed the first image screen's rendered visibility. I did try a sudden large movement in the Z-axis to make this plane disappear, but this led to problems due to motion blur. Similarly, the second image plane showing the screen recording of the wibbly Suzanne rendered visibility was keyframed to appear in the frame immediately after the first video plane was hidden from rendering. Again, alter the plane's video frames and offset in its materials to ensure correct running of the video in relation to the camera tracked scene. I next animated the quite interesting Suzanne menu option using keyframe coordinates and rotations and shape keys. All the objects for this are parented to the off symbol, which is also keyframed animate to appear just in front of the first screen plane and using big movement in Z. I only got problems with motion blur moving the video planes. I added many markers in the timeline which helped me with the proportional timing of events. I next added the first 3D Suzanne to the camera tracked scene, which starts with the same wibbly animation as the screen recording and appears to replace the screen Suzanne. The wibbly animation is to try and hide this transformation from the screen recording to the 3D Suzanne. Then keyframe animation right and left and out where she appears to be picked up. I carefully tweaked the materials and sunlight to make her appear as similar as I could to the bronzy matcap solid shader of the Suzanne in the screen recording. Next, I object tracked the fake cardboard Suzanne, again using perspective for the motion model. I used these trackers and got a solve error of 0.23. Back in the camera tracked scene, from the camera view, the object tracking appears correct, but from the top view you can see that the object tracking is scaled too big and is behind where the laptop screen at world origin is. All I needed to do was reduce the scale until the tracked object is where I need it to be in front of the laptop screen. I added a second 3D model of Suzanne, to which I added the object solver constraint and position to take over from the first 3D Suzanne. If there is a bit of shake in the tracked object, you can change its constraint to F-curves and then in the graph editor smooth the movement. But don't smooth too much, otherwise the difference in movement between the 3D object and your hand will be noticeable. This method could be used to smooth the camera tracking, but the fake laptop screen needs to be accurately matched to the iPhone video. The relative movements between the 3D Suzanne and my hand are a lot more forgiving. Next, I created the mask for my top 3 fingers and my bottom finger to obscure the rendered laptop screen. These are parented to the tracks on my fingers. Then I created a mask for my thumb that is parented to my thumb track and is used to obscure Suzanne's ear. Then I created masks for Suzanne's ear and upper right of head, which are parented to my thumb marker. To create these masks, I temporarily subtracted them from the rendered image like this to get the general basic shape. Suzanne's ear mask is subtracted from the fingers masks, added to the thumb mask, and the head is subtracted from this. This sounds complicated, but if you think about it, it makes sense. I did start using just one mask to do all this, modifying the mask as needed, but realised very quickly there must be a better way. Although the masks are parented to tracking points, a fair amount of rotoscoping is needed to tweak the masks into their right position. This involved doing a render image to update the image in the compositing editor, using V and Alt-V to zoom the image, and Alt and middle mouse button to move the image. The masks for the fingers and the ear are only needed when the fingers are obscuring the laptop. And when the head is turned and obscuring my hand, the edges of the mask don't need to be accurate, as the head will obscure my hand. This is rendered in Eevee, and here are the compositing nodes showing the mask nodes. I don't need a shadow catcher or background scene for this project. During the development of this tutorial, there were a few continuity errors between the screen recordings and some screen captures. For example, a different tab would be selected in the Properties panel, but rather than redoing a recording or setting up the screen again, I would simply use an image plane of the desired correct screen area and putting that slightly in front of the plane with the wrong image. The fake Suzanne that I picked up is visible near my fingers, and the tracking points on my hand could have been masked out, but I've spent far too long on this project, and I am keen to move on to new projects that I hope to make into shorter tutorials. The masking of Suzanne's ear and head would have been a lot easier if I'd picked up a 3D printed model of her with tracking points for the masks to be parented with. In retrospect, it might have been easier to do everything just as a single 3D scene rather than using multiple recorded screen planes and such. I will try this in a future project where I enter inside the Blender screen. I really hope some of this is interesting or useful and welcome any constructive criticism. If you would like more tutorials, then please subscribe. Thank you.